Hey everybody, my name is Snyder, and today I'm going to talk to you about a climbing route recommender that I constructed. So a roadmap where we're going to go in today's talk is first we're going to talk about motivation, next we'll talk about the data collection process, after that we'll talk about the recommenders that I constructed, followed by the byproducts that came out of constructing them. After that we'll talk about some conclusions, followed by any future plans, and finally we will demo an application that encapsulates all of this work. So motivation. Finding a new climbing route can be a cumbersome task. You need to comb through guidebooks or scour Mountain Project, but this isn't necessarily easy because there's a lot of books to read, and Mountain Project's search utility is not known for being the greatest. It just doesn't have a lot of features that you can use to filter routes by. So one question that we can ask is, can we improve this search utility? And ultimately we want to know whether or not we can have routes recommended to us. So the data collection process. I web scraped Mountain Project and obtained about 250,000 routes, 315,000 comments, and a few million each of route ratings, route completions, and route to-dos. From the scraped data, I cleaned it and exported it into a Postgres database, and this has things like a route's type, difficulty, height, all the route's completions, route ratings, route to-dos, and all the comments for any given route. So let's talk about the recommenders. So first you need to know that routes are rated by users from 0 to 4 stars, and on the right we can see the distribution of star ratings by frequency. So you can see that the mean value is somewhere near 3, indicating that most routes are rated favorably. So I created 3 separate recommenders. The first is a TF-IDF text similarity recommender that uses a fixed vocabulary of climbing terms. The second is an ALS matrix factorization user similarity recommender. And finally, I used a KNN item similarity recommender. So the ALS optimal hyperparameters were found to be a rank of 150 and a regularization parameter of 0.15, and the number of neighbors to use for the KNN recommender was found to be 50. In addition, each recommender takes filtering conditions, and this is because we want control of a route's difficulty, location, type, etc. Furthermore, we need to figure out the minimum number of ratings that each climb should have in order to optimally train our models. And so to do this, we look at how the minimum number of ratings affects RMSE as well as survivorship, where survivorship is just the number of users divided by the total number of users that we have. So we see that a minimum number of ratings per climb of 20 leaves us with around 90% of our user base, and still leaves root mean squared error relatively low. So an RMSE of 0.892 is our baseline, where every user just rates every climb as the average rating of all climbs. And so comparing the performance of each model, the TF-IDF, the performance isn't quantifiable, but it does make very fast predictions. The ALS is relatively robust to the cold start, makes predictions relatively slowly, and has an RMSE of around 0.698. The KNN model is pretty simple, has intermediate prediction time, and has an RMSE of 0.675. So some byproducts that come out of these recommenders is we actually created a data pipeline that serves the data to the recommenders, but this data pipeline serves as a search functionality that we can use to filter routes by, and it's actually a massive improvement over the Mountain Project search functionality. So conclusions. We scraped nearly the entirety of Mountain Project. About 99% of the data that lives there is contained in this database. We created a data pipeline that massively improves search functionality, and we created 3 recommender systems to recommend routes to users. So future plans. So I want to ensemble some or all of these recommendation engines together to make better predictions. And I want to add a reinforcement aspect where users can indicate whether or not a recommendation is a good one. If there are any questions, feel free to reach out at either the channels linked below. And without further ado, let's look at this application. So this is the climbing route recommender. As an about page, you can go read it on your own time, as this website should still be running. And here's the search utility. So say I'm interested in all the sport routes that are between, I don't know, let's say 5.7 and 5.10b, and I'm interested in the ones that are within 50 miles of Boulder, Colorado, and there will probably be a lot of them. So we can do that. So every route here should be within 50 miles of Boulder, Colorado, based on the latitude and longitude. And clicking one of these links will take us over to the Mountain Project page, but you can see some stats here just to give you an idea of what you're looking for. But the real meat of this application is getting route recommendations. So let's say that we are interested in a climb similar to one called Separate Reality, and this is a quintessential roof crack climb in Yosemite Valley. So Separate Reality is the route URL we're going to give it. We're interested in trad routes, and let's say that we are looking for routes between, how about 10b and maybe 10d, give it a kind of narrow range. And maybe we're only interested in going to El Dorado Canyon to climb these. And let's make sure that it's not terrible and has a decent number of ratings. So if we try and get a similar recommendation, it comes back pretty quickly, as I said, and all of these climbs should have similar keywords to Separate Reality. So the big two are roof and crack. So maybe let's take a look at Whiplash here. So Whiplash is another one of El Dorado's best winter climbs, and yeah, roof crack. So we can see that we are getting similar keywords being found in these climbs. So yeah, feel free to check it out. And once again, if you have any questions, feel free to reach out at any of these channels. Thanks.